Hi, in this video, we are discussing the numerical number 6 from the exercise for the chapter Laws of Motion, which is the fourth chapter for 11th standard physics syllabus. Now, this is a question which I like to call it a pretty straightforward question, but the given values are given in such format that this question can appear to be a little complicated, but it's not. Trust me. So in order to uncomplicate this question, let's start with a diagram. Okay, so this diagram illustrates whatever is happening in this particular question. So as per the question, we have a tanker and this tanker has some quantity of oil. To be specific, it has 40,000 liters of oil. And we are required to take this oil from the tanker and transfer it to a storage tank. The only challenge over here is this tank is not on the ground, but rather it is at a height h from the ground. Now, under normal condition, this is not possible because the gravitational force of Earth would not allow oil to get transferred in the storage tank. So we need a unit, or as we like to call it, a device such as pump, which would do some work in transferring this oil at a height h against the gravity. So as I said, we have a pump which does some work against the gravity, and we need to calculate the rate at which this work is being done. So basically, we need to calculate the power of the pump. That's the problem statement. Now, this is the diagram that shows the real life scenario for this particular problem. But if we need to calculate the power, we have to use a relatively easier diagram or simpler diagram. Now, as per this diagram, we have a block of oil with some mass, and this block of oil is traveling under the influence of some force in the vertical direction. And this distance in vertical direction is h, and based on this scenario we need to first calculate the work done, and then we need to calculate the rate at which the work is done by this block of oil. Okay, so now that we have a better understanding of what's happening in this question, let us start our solving process. First, let us write all the given data that's been given to us. So all this data has been given to us in the question. So the first quantity that we know is the volume of the oil, which is 40,000 liters. Now, for simplicity of calculation, we need the volume in meter cube. So we convert liters into meter cube, and the ratio is 1000 liters is equal to 1 meter cube. So 40,000 liters becomes 40 meter cube. Now, the second quantity that's been given to us in the question is the density of the oil, and this density is 0.9 grams per cubic centimeter. Again, this particular unit is not an SI unit, so we need to convert it into an SI unit, that is kg per meter cube. And the conversion ratio is 1 gram per cubic centimeter is 1000 kilograms per meter cube. So 0.9 becomes 900 kilograms per meter cube. We know the distance traveled by the oil in the vertical direction, that is height h, which is 10 meters, and we know the time it took for the transfer of the oil, that is 30 minutes or half hours, and in seconds it becomes 1800 seconds. So this was it for the given data. Now let's see our to find section. So under the to find section, we need to find only one quantity, that is the power of the pump. To find this particular quantity, we need certain formulas. First, obviously, we need the formula to calculate power because that's the desired quantity. And we know from the definition of power, it is the rate at which work is done. So it is work divided by time. We know the time as it's given to us, but we don't know work. So we need to calculate work. So as per the definition of the work is a dot product of force and distance. In this case, the distance is the vertical distance h, and force is the force that counters weight, that is mg. So another formula for work is mgh. But the problem over here is we know g, we know h, but we don't know mass. But we can calculate mass because we have been given certain quantities. To be specific, we know the density and volume, and from this it's pretty easy to calculate mass. So these are the three formulas which we will be using to write our solution. So there are two approaches over here. We can either individually calculate all these quantities and then finally substitute in this formula, or we can use all these three formulas to build us a hybrid formula. Okay, so where we represent W in terms of mgh and then M in terms of rho and V. So we sort of got a hybrid formula for our power. Now, the only thing remaining in this particular equation is to substitute the given values. So let us substitute all the values. All the values are in SI units. And if we do the calculation, 900 ones are, 900 twos are, 2 ones are, 2 20s are, 20 into 10 into 10. From this, we get the value of the power for our pump. That comes out to be 2000 watt. Watt is a unit of power. But we have another unit for power which is quite popular in our day-to-day usage, that is the kilowatt. Okay, so we will express our power fine in the final form in terms of kilowatt. So it comes out to be 2 kilowatt, and in terms of a statement, this will be the given statement, that is the power of the pump is 2 kilowatts. And that's it. The numerical is done. If you want a PDF of this solution, it's available in the description. So make sure you check that as well. With this, I hope this helped you. Thank you.